MNOs, mobile network operators today are under, I would say, tremendous pressure to speed up their rollouts, speed up their deployments, and at the same time, they have to deal with multiple complex fiber technologies. And over past several years, I would say that there's been a significant, I would say, evolution in the RAN architecture, moving from copper to fiber. And if we look at fiber-based mobile installations, they do add a lot of advantages. First one being power consumption. We're talking roughly 50% less power with these new type of installations. Second point on that side in terms of advantages is ease of installation, just the fact that you're replacing the heavy copper cables with fiber, a lot easier to do the installation. And also on that side, in terms of advantages, is I would call BBU location flexibility, where the baseband unit or the base station no longer needs to be at the bottom of the tower. It can be located miles away from the actual antenna site. But in terms of fiber technologies, it also adds a lot of challenges. And for one, fiber is a lot more fragile than copper-based installation. Precautions have to be taken by the contractors and the mobile network operators in order to really ensure that fiber does not get damaged, does not get dirty. Also, you have to consider that how do you pinpoint exact location of, let's say, a fiber issue? You have maybe a macro band or a faulty connector. You have to be able to find those issues in those installations. And there's also the fact now that there's active optical components inside that link between what we call the baseband unit and the RH at the top or at the rooftop. And these active optical components, the SFP modules, have to be validated, meaning that link has to be validated. You have to ensure that the SFP is properly seated inside the RH. You have to ensure that it's the correct one. You also have to ensure that the fibers that are plugged into the RH are properly plugged in. So those are very, very typical issues that we see moving towards this new type of installation. But on top of that, I would say that there's another challenge that MNOs and their team are facing today is the fact that a lot of them are very well-versed in terms of RF, have great expertise in terms of RF, but maybe new to fiber. So this really increases challenges for them. The moving towards what we call method and procedure, these method and procedures can be used to really overcome these challenges. And the idea there is to really accelerate mobile deployments while really preventing repeat calls and tower clients, which are very, very costly. So over the past several years, we at EXFO, we work very, very closely, and we continue to work very closely with Tier 1 MNOs around the world and their contractors. And what we've done is we spent a lot of time developing what we call our frontal test solution and really develop a MOP, a method of procedure that we call for mobile installations. And it's really, the idea there is really a 3-step process to really ensure what I would call a perfect mobile installation. And step one is really comes down to fiber connector inspection. And I would say this is really the basis of any fiber network is clean connectors. And this is really to ensure proper communication between the BBU, the baseband unit, and the RH at the top. So that's step number one to really overcome these challenges. Step number two is what we call fiber characterization, looking at the complete fiber span from bottom to top, top maybe a rooftop or maybe a tower top, and really ensuring that there's no significant optical loss along that fiber span. So it could be making sure that there's no macro bends, there's no bad connectors along that fiber span. And it's really to allow for a perfect digital optical signal quality between the BBU and the RH. So that's step number two. Step number three is what we call a CIPRI or OBSI link validation. And this is really what we call it's a protocol that is used to transport digital RF, the IQ data between BBU and the RH. And this link validation test, is really to confirm that the RH, the remote right ahead that's located at the top, is fully operational. So also new in the mobile industry is really a fourth step where once the physical installation is completed using the same EXFO test solution, the BBU can actually be emulated at the RF level over the CIPRI or OBSI link to actually start exercising the RF transmission and validate that there are no issues in terms of the transmission, so the downlink side, and also in terms of the receive, so the uplink side. With these three steps, when performed I would say during the installation, the fiber connector inspection, as I mentioned, fiber characterization, link validation, have really proven to be a huge cost and time saver for MNOs and also for the contractors. Just recently talked to the MNOs that we work with and the contractors. Before implementing this three-step procedure, contractors would typically have to return to mobile cell site roughly 50% of the time. So tremendous savings for, again, MNOs and contractors. And by implementing what we call the three-step procedure, this has significantly reduced the repeat visits and tower climbs, which basically brought it down to nearly zero in terms of those tower climbs. So really saving on installation costs and really ensuring the deployments are on time and on schedule. Again, this is really critical for mobile network operators today. Probably, I would say another key point that we're seeing more recently is that Tier 1 MNOs around the world are starting to mandate that their contractors, their team that are doing the installations, perform these three-step procedure during the installation. And now with what I would say with the move towards CRAN, towards centralized radio access networks, where the BBUs are centralized, in some cases, miles away from the actual antenna site, maybe in a data center, there are even more benefits to the three-step procedure. A CRAN architecture can have fiber spans up to 10 miles long, 15 kilometers, and also have multiple fiber interconnections. So there's, I would say, a lot more potential failure points along that fiber span, and a lot less optical link budget, so a lot less room for error. CRAN, I would say, is something that's important to mention here is CRAN we consider as a necessary step in the RAN evolution, really paving the way for 5G, given that centralization of the BBUs will be key in 5G. The fiber infrastructures that are being built today for CRAN will also be used for 5G. So it's critical that MNOs incorporate proven installation procedures for their CRAN deployments using frontal test solutions that will accurately and quickly validate the fiber foundation and the optical link. And this will enable a very smooth transition towards tomorrow's 5G networks.